Hello, my name is Muammar Abradovic, and in this video I will be going over web work assignment number 4, Thomas differential equations, problem number 7. In this problem, it's asking us to find the critical points of the Thomas differential equation, which is dx over dt equals f of x equals 11x minus x squared minus 18. It's also asking us to analyze the f of x to determine whether each critical point is stable or unstable. So, to find out if this is true or not, we go over here to the work done for this problem. So, to find the critical points, we take 11x minus x squared minus 18 and have it equal to 0. Then we rearrange it to have a better understanding of the equation, which is negative x squared plus 11x minus 18 equals 0. Then we factor out the negative, causing us to have x squared minus 11x plus 18. Then we try to find the factors that make this equation using the product sum table here. The product is 18 and the sum is negative 11. The two common numbers that make these numbers up is negative 9 and negative 2. So we have x minus 9 and x minus 2. Now, then we take x minus 9 and have it equal to 0, and then we add both sides to 9, by 9, I mean, to get x equals 9. And then we do the same thing for x minus 2, where we add 2 on both sides and get x equals to 2. Now that we've done critical points, we now have to find the stability, which we can do by analyzing the intervals determined by the critical points. So first, for x is less than 2, x is set to equal 0. And we input 0 into f of x, giving us negative 18. And since negative 18 is less than 0, it decreases. Next, for the interval 2 is less than x, which is less than 9, we set x equal to 5 and input 5 into f of x, giving us 12. And since 12 is greater than 0, it increases. For x is greater than 9, we set x equal to 10, and by doing so, we get negative 8 when we input it into f of x. Since negative 8 is less than 0, it decreases. And then now we go back up here to this diagram that's done for the intervals. As you can see, between 2 and 9, it's increasing, and between 0 and 2, it's unstable because it's decreasing. And back here, since 2 to 9 is increasing, 9 is stable, while x equals 2 is unstable. Right? And now that we found the critical points and their stability, we now have to find the differential equation. We have to solve the differential equation with the initial condition x of 0 equals 1. So here we take dx over dt equals 11x minus x squared minus 18 and separate the variables from one another. By doing so, we get dx over 11x minus x squared minus 18 equal to dt. Then we just take the equation below d of x and into a factored form. And then we use partial fraction decomposition to help with further understanding of the equation. Next, we use cross multiplication, where we get 1 equals a times x minus 2 plus b times x minus 9. Next, to find a, we set x equal to 9, and then fill out, and then input 9 into where x is in the equation, giving us a equals 1 over 7. Then we do the similar process for b, for finding b, where we input 2 into the equation, giving us b equals negative 1 over 7, as seen here. Then we just integrate both sides to give us these equations right here. 1 over 7 times ln x minus 9 minus 1/7 ln x minus 2 equals negative 7 plus c. Next, we simplify the left side to get 1/7 times ln times minus 9 over x minus 2. Then we multiply both sides by 7, giving us ln times x minus 9 over x minus 2 equal to negative 7t plus minus 7c. Then we continue simplifying further, and until we keep doing so, we get x minus 9 over x minus 2 equal to ce to the negative 7t. Now we try to apply x of 0 equals 1, the initial condition, into the formula to figure out what c is. By doing so, we get c equals 8. Then we input c into the equation, giving us x minus 9 over x minus 2 equal 8e to the negative 17. Then we do some cross multiplication to get x minus 9 equals 8 times e to the negative 17 times x minus 2. And then we add 9 to the right side, and we also subtract 8x e to the negative 17 to the left side, giving us x minus 8x e to the negative 17 equal to 9 minus 16 e to the negative 17. And finally, we've finished it off by dividing each side by 1 minus 8e to the negative 17, giving us x of t equals 9 minus 16e to the negative 17 divided by 1 minus 8e to the negative 17. And now we go back here to check to see if our answers are correct, and they are. So, I hope this video was informative and helpful for anyone watching this. And thank you very much for watching, and have a nice day.